In this lesson, we're going to look at how we can take a quadratic equation in standard form and convert it into vertex form. In order to do this, we must follow the steps of a process called completing the square. Before we begin, let's go through the three equation formats that you can find for a quadratic equation or a parabola. The first and most basic is what we call standard form. The general format for standard form is y equals ax squared plus bx plus c, where a represents the direction of opening, so it tells you if your parabola opens up or down, and the c value represents the y-intercept, so where the parabola will cross or touch the y-axis. The second format is factored form, and it takes on the form y equals a multiplied by x minus s multiplied by x minus t. Again, the a value represents the direction of opening, and s and t represent the values of your x-intercepts, also known as the roots, or they could also be called the zeros. So these are the values where the parabola will cross or touch the x-axis. And finally, the third form is vertex form, represented by the format y equals a multiplied by x minus h squared plus k. Again, a is always the same. It represents the direction of opening. And we have the letters h and k, which represent the coordinates or the values of your vertex. So underneath the general format for standard form, I have an example of an equation in standard form, y equals 2x squared minus 2x minus 24. And so I can take this format in standard form and I can convert it into factored form by using a process or method of factoring. And so 2x squared minus 2x minus 24 in factored form would be 2 multiplied by x minus 4 multiplied by x plus 3. If I wanted to take this equation in factored form and convert it back into standard form, I would just have to expand it out. So I could use the FOIL method and multiply out my binomials in these brackets, and I can simplify it back into standard form. But now, if I wanted to take this standard form equation, I could also convert it into vertex form. And that's what we see over here, negative 2 multiplied by x minus 1 squared plus 5. And so today what we're going to talk about is how do we take something that is in standard form and how do we turn it into an equation in vertex form. So we know that if we have an equation in standard form, and then we factor it to turn it into factor form, we could use the x-intercepts or the roots and find the vertex that way. And so that's the way that we've kind of been doing it thus far. And it does work, and it is a foolproof way of doing it. So let's just kind of quickly review that, and then we'll talk a bit about how we can find the vertex through another method. So the first equation I have here is y equals 2x squared minus 14x plus 24. So it's in standard form, and I know this because I can see the format kind of outlined for me. I have my ax squared, I have my bx term, and I have my c term. So the first step to factoring is to always check if you have a common factor that you can pull out from each term in the equation. So when I look at the coefficients, I see 2, 14, and 24, and I know that 2 is a common factor amongst all three. So I'm going to divide each term out by 2, and we'll write what is left over. So my common factor is 2, so I need to include that in the front, and then what would be left over from the division would be x squared minus 7x plus 12. So now I'm left with a trinomial, a three-term expression, and I want to see if I can factor this expression a little bit further. And so what I can see is if there are two numbers that multiply to give me positive 12, but also add together to give me negative 7. So I'm going to use the product and sum method to see if I can factor this further. So I know that negative 3 multiplied by negative 4 will give me a positive 12. And negative 3 plus negative 4 will give me -7. So I'm able to get that C value and I'm able to get that middle B value. And the two numbers that give me those numbers are -3 and -4. So -3 and -4 are going to be my factors. All right, so here is my final equation in factored form. It's 2 multiplied by x minus 3 multiplied by x minus 4. So here are those two numbers, -3 and -4, that we came up with. So this is the equation that's now in fully factored form. From this format, what I'm able to do is pull out or identify my x-intercepts. So one of them is going to be a +3 and the other one is going to be a +4. So now that I know my two x-intercepts, I can actually go ahead and figure out what the vertex is. The first thing I need to do is find my axis of symmetry. And so to find the axis of symmetry, I need to take my two x-intercepts, add them together, and divide by 2. So one of my intercepts is this +3. To that, I'm going to add my other x-intercept, which is the 4, and I'm going to divide by 2. So 3 plus 4 is 7, divided by 2 is 3.5. So the x value of my vertex, or half of my vertex, is at 3.5. Now I need to go ahead and find the corresponding y value. And to do that, I need to take 3.5 and I need to put it back into the original equation. So I could do that one of three ways, actually. I could take 3.5 and put it back into the original equation. I could plug it into this partially factored equation, or I could plug it into this fully factored equation. Either way, I'm going to get the exact same answer for y. So I decided to take my 3.5 value and plug it into the fully factored form of the equation. So wherever I saw the letter x, I replaced it with the value 3.5. Okay, I subtracted inside each bracket, got my answers, and then it's just a straightforward multiplication. So 2 multiplied by 0.5 multiplied by -0.5, which gives me a y value of -0.5. So if I put together my x value and my y value, that's going to give me the coordinate point for my vertex. So we can take an equation that is in standard form, we can go through the process of factoring it to turn it into factored form, and then we can perform some additional steps to find the vertex. So what if we wanted to go from standard form directly to vertex form? So here's a brand new equation. 0 equals 3x squared minus 4x plus 5. So this is an equation that is in a standard form. So if I wanted to turn it into vertex form, well, I could try, I guess, to start factoring it and see if there's anything that I could do in that way. But there is no common factor that I could pull out between 3, 4, and 5. So common factoring is not going to work. I could then try to factor using decomposition. My a value is not 1, it's 3. So I would have to do 3 multiplied by 5, so that would give me 15. So I need two numbers that would multiply to give me 15, but they also have to add together to give me -4. And there are no number combinations that are going to work out. So it's not going to be easy to find the x-intercepts through factoring, and that's going to be our problem. However, it can be helpful to convert a standard form equation to vertex form when you need the vertex and you need that information. And so the method that we're going to use to do this is called completing the square. Before we dive into the steps for completing the square, we're just going to do a little bit of a warm-up, and we're going to take a look at a concept called perfect square trinomials. So remember, if we were to expand the expression x plus 3 squared, that really just means that you would take this expression and you would write it out twice, since it is squared. and then you would expand this out by using the FOIL process or the FOIL method, and you would end up with the expression x squared plus 6x plus 9. So this expression is actually called a perfect square trinomial. There is a very specific relationship between x plus 3 squared and x squared plus 6x plus 9. There's also a little bit of a shortcut that you can apply to take an expression like this and turn it into its fully expanded standard form expression. So yes, you could totally expand it out, write it out twice, and then FOIL it to get the standard form expression. But for a perfect square trinomial, there is a shortcut. So here's the shortcut. If you are looking for the b value or the middle number in your standard form equation, you can take your value or your number and you're going to multiply it by 2. To find the c value or the end number in your standard form equation, you're going to take your number or your value and you're going to square it. So let's take these rules and apply it to the example that we just looked at. So our expression that we started with was x plus 3 squared. So I want to take this and put it into standard form. So the first value is always just going to be a simple x squared. We don't have to worry about the number in the front. So the first value is x squared. Then to get the middle value, so this is your b value, we need to take our number and multiply it by 2. So our number that I'm referring to is a positive 3. So if I take positive 3 and I multiply it by 2, that's going to give me a positive 6. So I'm going to put in a positive 6. So there's my b value. To get the c value, so the number at the end of my equation, I'm going to go back and take my number, which is a positive 3, and I'm going to square it. So a positive 3 squared is a positive 9. So I'm going to put that into my equation. And so there we go. We generated the exact same expression that we had in the original sentence statement at the top. X squared plus 6x plus 9. So we're going to take that shortcut and we're going to try it out with a couple of different examples. So I have a bunch of different equations in standard form and a couple that were listed in factored form. And we're going to try to convert from one to the other using that shortcut. So I'm actually going to start with example B because it looks similar to the one that we just did, and so let's just practice to kind of refresh our memory. So in factored form, we have x plus 5 squared, and we want to use our shortcut to turn it into a standard form equation. So a perfect square trinomial in standard form. So our first term is always going to be x squared, okay, and then we need to figure out the b and the c values. So again, we're going to go to our number, which is a positive 5, and I'm going to multiply it by 2. So positive 5 multiplied by 2 is a positive 10, and I'm going to put an x. That is my b term, or my middle term in my standard form equation. And to get the end term, or my c value, I'm going to take my number, which is a positive 5, and I'm going to square it. So a positive 5 squared is a positive 25. And there we go. So if I were to take this equation in standard form and I were to factor it, it would give me x plus 5 squared. Now remember, just so you don't forget, x plus 5 squared is the same thing as saying x plus 5 times x plus 5. It's just we make it a bit simpler or shortcut it by putting the squared because it's the same thing written twice. Okay, so let's try it out again now with example C. Actually, example C is the one that we did earlier. It's just a repeat. So positive 3 multiplied by 2 is positive 6, and a positive 3 squared is going to be a positive 9. Okay, let's try example D. So I have x minus 4 squared. So this time it's a minus 4, but it doesn't matter if it's positive or negative, the same rules are going to apply. So a negative 4 multiplied by 2 is a negative 8. So that was already filled in for us, and that's how they got this negative 8. Negative 4 times 2 is negative 8. And a negative 4 squared is a positive 16. So you just have to be very careful with the signs. Remember, if you're squaring something that is negative, it is going to become a positive. And so we have a positive 16. Okay, what if we wanted to go the opposite way? So we have an equation that is in standard form, and we want to turn it into an equation in factored form. To do this, we're actually just going to perform the opposite operations of what we just did. So instead of multiplying by 2, we're going to take our b value and we're going to divide it by 2. And we're going to take our c value and we're going to square root it. Now you'll know that you did it correctly because by performing these two operations, you actually should get the same number. And so that number is what is going to appear inside your brackets in factored form. Okay, so let's try this out. So our original equation here is x squared minus 4x plus 4. And so what we're going to do in our factored form space, we're going to make an open bracket. We're going to put a squared symbol. We have the letter x, so we're going to put in an x, and then we just have to figure out what number is going to fill in this bracket here. So I'm going to go back to my standard form equation. My b value is negative 4. So negative 4 divided by 2 is negative 2. Okay, so now let's check and see. If I were to take negative 2 and square it, I should be able to regenerate this c value here. So negative 2 squared, or negative 2 to the power of 2, is a positive 4, and that's correct. Also, if I take the square root of 4, I get 2. So that works out too. All right, so let's try this example down here. So example E, they've given us half or the majority of the standard form equation. We need to figure out the missing c value, and we also need to figure out the equation that corresponds in factored form. So we have enough information to do this. So in my factored form space, I'm just going to go ahead and make an open bracket. I'm going to put a squared, and I'm going to put the letter x in. So to figure out what number goes inside my bracket, remember I just need to take my b value from my standard form equation, which is negative 2, and I'm going to divide it by 2. So if I take negative 2 and divide it by 2, I get negative 1. Okay, so my factored form equation is going to be x minus 1 squared. Now all that's left to do is figure out this missing number here. So I'm going to take negative 1 and I'm going to square it. So negative 1 squared is a positive 1. Okay. Another pattern that you can kind of start to notice if you take a closer look, whatever the sign is for your b value, that is going to be the same sign that appears inside your factored form bracket. So here, my b value is a positive 10, so my factored form is a positive. Positive, positive. Negative, so there's a negative inside my bracket. There's a negative here, so there's a negative inside my bracket. All right, the last one, I've got x squared plus 10x plus a missing number. So if I want to create my factored form expression, I'm going to make a bracket, put a squared, put an x. So I need to take my b value, which is a positive 10, and I need to divide it by 2. So positive 10 divided by 2 is a positive 5. All right, now to get the c value, I need to take positive 5 and I need to square it. So that's going to give me a 25. So the ultimate question is, what does this have to do with completing the square? How is this going to help us when we take an equation in standard form and we want to turn it into vertex form? Well, a lot of the same principles that we used here, dividing by 2 and squaring or square rooting, those principles are going to carry over in the steps that we're about to see for completing the square. So completing the square is an algebraic method that you're going to use to convert equations from standard form into vertex form. So just to recap before we begin, we're taking something in ax squared plus bx plus c format, and we're turning it into ax minus h squared plus k format. So our first equation that we're going to work with and that we're going to convert is the equation y equals x squared plus 4x minus 5. So I have the steps all kind of written out, and we're going to go together step by step to take our equation and convert it. So our first step is to factor your a value from the first two terms to make the coefficient of x squared 1. The c term remains unchanged. So that means don't touch the c term even if you know that it is a multiple or a common factor of your a value. So what does that mean? The first thing we want to do is make sure that the a value, or the number in front of your x squared term, it's got to be 1. So we're kind of lucky in this example because our a value is already a 1. But there are going to be equations, like we'll see later on, where there is an actual value in front of the x squared. But we don't want that value there, so you're going to have to factor it out. Now, normally when we factor out a common factor, we factor it from all three terms in the equation. But with completing the square, you're only going to pull that factor from the first two terms. So what I'm going to do is I'm going to put a bracket around those first two terms because we're only going to focus specifically on those two. So that's why in the instructions they tell you not to touch the c term, okay? So again, we're lucky. Our a value is 1, so we're not going to pull anything out because there really isn't a point to pulling out or factoring out a value of 1. So we're going to go ahead and proceed to the next step. So step 2, we need to create a trinomial that is a perfect square, like the pattern that we just discovered in the previous slide. So what we're going to do is we're going to take our b value. So our b value is negative 4. We are going to divide it by 2, and then we are going to square it. We are going to add and subtract this value inside the bracket beside the x term. So let me show you what I mean by all of that. So we're going to take our b value, which is negative 4. We're going to divide it by 2, and we're going to square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. So what I'm going to do is I'm going to take that value of positive 4 and I'm going to put it inside my bracket. And so I'm going to add and I'm going to subtract that positive 4 value. Okay, and then the negative 5 is still on the end. So just to recap all of that, I took my b value, which was negative 4. I divided it by 2. I squared it, and that gave me a value of 4. So I took 4 and I added it and subtracted it inside the same bracket, and then I just recopied out the number on the end, which was the minus 5. Step 3, inside your bracket, you're going to isolate your perfect square. So to do that, what you're going to do is you're going to take your value that you're subtracting and you're just going to move it outside of the bracket. So you're going to take it out of the bracket. Now, when you take it out of the bracket, you just need to make sure that you pay attention to the a value, so the number that's in the front. Because anytime you pull something out of the bracket, you need to multiply it by your common factor that's in the front. Now, again, we're very lucky with this question because your common factor in the front here is just 1, right? We didn't have a very particular a value that we were working with. So if I take -4 and pull it outside of the bracket, well, -4 multiplied by 1 is just -4. It's going to stay the exact same. So I'm going to have y equals x squared minus 4x plus 4. I'm going to close the bracket off here. This -4 is going to come on the outside, and the -5 is still there. Okay, my next step is to collect like terms. So my like terms are these terms, these plain numbers that are just kind of hanging around on the end of my equation. I can put these two terms together. So a -4 minus 5 is a -9. So my equation is going to become x squared minus 4x plus 4, close the bracket, and then I have a -9. All right, we've reached the last step, and the last step is for you to factor your perfect square. So this is what we did when we were working with those perfect square trinomials on the previous slide. So we need to figure out what number is going to go into our little bracket, right? So we have our bracket, we have our squared number, okay? So we just have to put in an x, and then remember the pattern, you're going to take this b value and you're going to divide it by 2. So -4 divided by 2 is a -2. The outside number, -9, that's going to stay the same. You're just going to recopy it. And there you go. You have an equation that is now in full vertex form. You have your a value, you have your h value, you have your k value. So let's take a look and see what information we can pull now that we have our equation in vertex form. So for this parabola above, what is our vertex? We got to fill that in here. So remember, when you are reading your vertex, the h value is the number that's inside the bracket. However, the rule is that you need to read it as the opposite. So in the actual equation, it looks like -2 for our h value, but we're actually going to report it as a +2. Okay, your k value is the value on the outside of the equation. That stays exactly as it is. So it shows up in the equation as a -9. So that's the number that we are going to report. So our vertex for this parabola is located at the point 2 and -9. The next thing we need to figure out is which way does the parabola open, because they're asking us. Remember, the parabola direction of opening is given by your a value. Our a value is a 1, but it's also a +1. So because our a value is positive, that tells us that our parabola opens up. So it's a parabola that's going to look like a regular, normal, U-shaped parabola. So because our parabola opens up, we are going to have a minimum value, right? Our lowest point is going to be down here where the vertex is at 2 and -9. Okay, they want to know what is that minimum value. Well, the minimum value is just the y value of your vertex. So our y value is -9, right? The lowest point that our parabola can get to is a -9. And this happens when our x value is 2. So you only get that minimum value of -9 when your x value is 2. All right, that was a lot of steps to go through. So we're going to try it together again for another equation. And this time you're going to see that when your a value is not 1, okay, there's a couple of extra things that we have to take into account. So we're going to convert this equation, 2x squared minus 4x plus 6, to an equation in vertex form. So I recopied the equation. Your first step is to group or put brackets just around the first two terms of your equation. So that's going to be your x squared term and your x term. The plain number is going to be left out of that bracket and it's just going to hang out at the end of your equation. Your second step is to look at the terms inside of your bracket, and we just want to focus on the numbers, not the letters. And we just need to figure out if there is a common factor that we can pull out. So between 2 and 4, there is a common factor. There's a common factor of 2. So I'm going to pull that out. So I'm going to pull out 2, and what would be left is x squared minus 2x. The plus 6 is still there at the end of our equation. Our next step is to work with our perfect square trinomial. So what that means is I'm going to focus just on this b value here. So our b value is -2. And what we need to do is take -2. We're going to divide it by 2. And we're going to square that answer. So -2 divided by 2 is -1. -1 squared is a +1. So now that I know that, I'm going to go back to my equation. Okay, we're going to keep the y, we're going to keep the 2, we're opening our bracket, we've got x squared minus 2x, and then inside the bracket, we're going to take the number that we just figured out, the 1, and we are going to add it and subtract it all inside the bracket. So you close off the bracket, and then we still have that +6. Our next step is to take the number that we subtracted, so the -1, and we're going to pull it out of the bracket. Now, when we pull this -1 out of the bracket, you also have to multiply it by the number that is at the front, that common factor that we pulled out at the very beginning. So we have a -1, but we need to multiply it by 2. So a -1 times 2 is a -2. So we're going to recopy what we have in our equation. So we've got 2 multiplied by x squared minus 2x plus 1. And then this -2 is going to go on the outside of the bracket, and we still have a +6. Our next step is to collect like terms. So we're referring to the two terms that are at the end or the back end of the equation. So -2 plus 6 is a +4. So we're going to again recopy everything else. And then on the end, we now have a +4. Our last step is to factor this perfect square trinomial that we have inside the bracket, and we're going to shortcut it like we learned. So we have the a value. You're going to make yourself a smaller bracket. You're going to square that bracket, and you're going to keep the outside number. So we still have our common factor in the front of 2. We still have our +4 on the end. To figure out the number that goes in the middle, okay, remember you are taking your b value of -2 and you're going to divide it by 2. So -2 divided by 2 is -1. So -1 is the number that's going to go inside of that final bracket. So here is the equation in vertex form. So if we wanted to identify what the vertex actually is, remember it is a coordinate point. The first value, the x value of your vertex, that comes from the h value in your vertex form equation. So it reads as -1. However, when you report it in your vertex, you're going to report it as a +1. The second half of your vertex, the y value, that comes from the k value from your vertex form equation. So our k value is a +4, and you report it as a +4. So the vertex for this quadratic equation is located at 1 and 4. The last thing we can also identify is if this vertex is a maximum value or a minimum value. In order to do that, we just have to pay attention to the a value of our equation and the sign of the a value. So our a value is a +2. So because it is a positive a value, that tells me that the parabola is going to open upwards. And so that means my vertex of 1 and 4 is located at the bottom of my parabola, which means that it is a minimum. So here's another example of an equation that we're going to convert to vertex form. If you'd like to try it on your own, feel free to pause the video at this point, and then you can come back and check for a step-by-step solution. So I went ahead and recopied the equation, and remember our first step is to put brackets around just the first two terms in the equation. So that's the x squared term and the x term. Our next step is to look for a common factor between the two terms that are inside the bracket. Now we have a negative in front of the x squared. Remember, we don't see it, but there is a 1 in front of the x squared, and in particular this is going to be a -1. So in terms of finding a common factor between -1 and 6, -1 is going to be our common factor. So I'm going to go ahead and pull that out. So I have y equals -1. I'm not going to write the 1 because we normally don't write the 1 in math, so I'm just going to put a negative sign. And then I'm going to write what is left over in my bracket. So if I divide each of these terms inside the bracket by -1, that's going to leave me with x squared minus 6x. And we still have the +11 on the end of our equation. Our next step is to figure out our perfect square trinomial. So we're going to take a look at our b value, which is a -6, and off on the side I'm going to do -6 divided by 2 squared. So -6 divided by 2 is -3. -3 squared is a +9. So I'm going to take that number and I'm going to add and subtract it inside the bracket. So I'm going to recopy the rest. Y equals negative, open bracket, x squared minus 6x. And then here is where we're going to put a +9 and a -9. And then I'm going to close the bracket, and I still have my +11 on the end. Our next step is to take the number that we are subtracting, so for us that's this -9, and we're going to pull it out of the bracket. Now remember, when you pull this term out of the bracket, you need to multiply it by the common factor that's at the front of your equation. So for us, that is a -9 multiplied by a -1, because that was our common factor that we pulled out. So -9 multiplied by -1 is a +9. So I'm going to recopy. And that +9 that we just calculated is going to go on the outside of my bracket, and I still have my +11. The next thing I'm going to do is collect like terms. So I'm going to put together 9 plus 11, or positive 9 plus 11. So we keep everything else the same. And positive 9 plus 11 is a positive 20. And our final step is just to create the factored little bracket. So I'm going to keep the y. We still have our -1 in the front. I'm going to make a smaller bracket. I'm going to square that bracket, and I'm going to keep the 20 on the end. So we have an x that goes inside that smaller bracket, and to figure out what number goes in the middle, remember you're taking your b value and you're dividing it by 2. So -6 divided by 2 is a -3. So -3 is going to go inside of our bracket, and here's our equation in vertex form. So if we have to record our vertex or report the vertex, it's a coordinate point. Remember that the first value is your h value. So in our equation, the h value looks like a -3, but we're going to report it as the opposite, so it will be a +3. And the second half, or the y value, comes from our k value from our vertex form equation. Our k value is a 20, so I'm going to put that in. So our vertex is located at 3 and 20. Now, does this parabola have a maximum or a minimum point? Where is the vertex? Is it a max or a min? So to figure that out, we just need to look at the a value, and in particular, we need to pay attention to the sign of the a value. Our a value is a -1. So because it's a negative, that means that the parabola this time is going to open downwards, and our vertex is going to be located right up at the top. So when your vertex is on the top of your parabola, that means that this is going to be a maximum. So to summarize, we now know all three formats of a quadratic equation: standard form, factored form, and vertex form. If you want to convert an equation in standard form to factored form, you are going to factor the equation. If you have an equation in factored form and you want to turn it into standard form, you can simply expand or FOIL your factored form equation. If you have an equation in standard form and you'd like to turn it into vertex form, you will then have to complete the square, and that's the process that we focused on in today's video.